when I'm presented with a quadratic equation, like the one in front of us, the first thing I do is look to see if I can use square root property. And I notice that there's two variable terms, and if there's two variable terms, I can't just use inverse operations to solve. So I'm going to have to go through and use a different method. In order to use factoring or using quadratic formula, the first thing I have to do is put it into standard form. So I'm going to move the 35 over using inverse operations and subtraction, and I get the standard form of 6x squared plus 11x minus 35 equals 0. Again, now I'm in standard form, and I can approach the quadratic formula in a very systematic way. So just as a reminder of what the quadratic formula looks like, it's over here on the side of the screen. I need to identify a, b, and c, and then just plug them into the formula in the appropriate places. So if I use the formula, I get x equals opposite b, so negative 11, plus or minus the square root of b squared, or 11 squared, minus 4 times a, which is 6, times c, which is negative 35. And this is all divided by 2 times 6. When I solve quadratic formula problems, my first step is to get this number underneath the square root, which later we're going to call the discriminant, down to just one number first. So when I do that process, I leave everything else the same, and I get x equals negative 11 plus or minus the square root of 961, all divided by 12. That's the part that people seem to have the most trouble with, so I focus on getting that correct before I go any further. Now if I take the square root of 961, I find out that 961 is a perfect square, so x is negative 11 plus or minus 31 divided by 12. I have my two solutions because of the plus or minus. All I have to do now is break this up into the two solutions. So one of my solutions is going to look like x equals negative 11 plus 31 over 12, and the other one is going to be x equals negative 11 minus 31 divided by 12. There's my plus and minus. I just broke it up into two different pieces. So if I do just a little bit of math, on the left-hand side I get x equals 20 twelfths, and on the right I get x equals negative 42 twelfths. So my final answers when I reduce are x equals 5/3 and x equals negative 7 halves. Notice how both of these are rational solutions because I had this perfect square right here underneath my square root. So in the end, these are my final answers. They're the two numbers that if I were to plug back into my original equation up here, would make that equation true. And they're the only two numbers that would do that. So they're the two solutions to my quadratic equation.